In the vastness of the cosmos, a giant star looms with a destiny that could one day shake the universe, perhaps even reaching Earth in subtle but serious ways. This star is Betelgeuse, a massive red supergiant and one of the most prominent features of the constellation Orion. Over the past few years, Betelgeuse has exhibited unusual behavior, dimming significantly in 2019 and sparking global curiosity and scientific concern. Some believe this dimming might be a prelude to a cataclysmic supernova, a cosmic explosion that could outshine entire galaxies for a short time. Betelgeuse, also known as Alpha Orionis, is among the brightest and largest stars visible in the night sky. Positioned in Orion alongside another notable star, Rigel, Betelgeuse has always stood out. But what happened in 2019 changed how astronomers perceive its life cycle. NASA's Hubble Space Telescope and other instruments observed a massive ejection of matter from the star, a phenomenon never before documented in a red supergiant. While coronal mass ejections are common in our Sun, this particular mass loss from Betelgeuse was on a far greater scale, nearly 400 billion times more massive than the Sun's usual outbursts. This ejected gas formed a dense cloud that temporarily obscured part of Betelgeuse's surface, making it appear dimmer to observers on Earth. The event was so unusual that it raised new questions about what happens in the final stages of a massive star's life. Measuring the exact distance to Betelgeuse remains a challenge, but the star could be as close as 724 light-years from Earth, close enough in cosmic terms to warrant serious attention. With a brightness nearly 100,000 times that of our Sun, Betelgeuse burns through its fuel at an incredible rate. This intense energy output comes at a cost. It accelerates the star's aging process. Eventually, Betelgeuse will exhaust its nuclear fuel and collapse under its own gravity, leading to a supernova explosion. Depending on various factors, it may leave behind a neutron star or, if conditions are right, a black hole. The question many people ask is whether Betelgeuse poses a real threat to Earth. If a supernova were to occur within 50 light-years of our planet, the results could be catastrophic. The explosion would emit not only an immense amount of light but also high-energy radiation like gamma rays and X-rays. These emissions have the potential to damage or even destroy Earth's protective ozone layer. Without this layer, life on the planet's surface would be vulnerable to harmful ultraviolet radiation from the Sun. Historically, no supernova has been observed within our own galaxy since 1604, although one did occur in the Large Magellanic Cloud in 1987. About 169,000 light-years away. While that event did not pose a risk to Earth, it offered valuable insight into the mechanics of stellar death. A nearby supernova, however, could have far more serious consequences. Supernovae are not the most dangerous cosmic explosions known to science. Gamma-ray bursts, for example, are significantly more powerful and damaging, but they are still capable of wreaking havoc. They can sterilize planets, wipe out biospheres, and alter climates. Even years after a supernova, its lingering effects, like cosmic rays, can reach Earth. These highly energetic particles travel across the galaxy at near light speeds and can gradually erode the ozone layer, causing long-term exposure to radiation. When Betelgeuse does finally explode, the sight will be awe-inspiring. The star will become the second brightest object in the sky after the Sun. For several weeks, it will outshine the full moon and even be visible during daylight hours. Its brilliant light will cast shadows at night, creating an eerie and unforgettable spectacle. Yet, despite its brightness, the visible light from the explosion will make up only a small portion of the supernova's total energy. The greater concern lies in the invisible high-energy radiation it may unleash. While the initial flash of radiation is dangerous, it's the long-term effects that scientists worry about the most. If the radiation strips away Earth's ozone layer, the planet could be exposed to increased levels of ultraviolet radiation for years. Over time, cosmic rays from the explosion could also have a delayed but destructive impact on Earth's atmosphere. Still, it's important to note that while Betelgeuse is relatively close by stellar standards, it is likely far enough away to prevent catastrophic damage to Earth. Scientists continue to monitor the star closely, searching for signs of further instability. For now, Betelgeuse remains a giant ticking clock in the sky. Its final moments a mystery, its potential a reminder of the power and radiation from supernovae doesn't just bring brief moments of cosmic drama. It carries significant energy and long-lasting consequences. One clue that Earth has experienced such distant stellar explosions in the past lies beneath our oceans and on the Moon. Scientists have discovered traces of iron-60, a radioactive isotope forged in the heart of supernovae, embedded deep within seafloor sediments and lunar regolith. The presence of this isotope strongly suggests that Earth was showered by the debris of a nearby supernova within the last few million years. Although current models suggest there are no nearby supernova candidates that pose an imminent threat to life on Earth, astronomers have uncovered a more specific and potentially devastating risk. A certain type of supernova, formed under unique conditions, might be more dangerous than previously thought. When a massive star nears the end of its life and is surrounded by a dense disk of gas and dust, the supernova's shock wave can collide with this material, heating it to extreme temperatures. This interaction creates a tremendous burst of X-ray radiation. Unlike visible light, X-rays from such an explosion carry far more energy and can travel immense distances. If Earth were within 150 light-years of one of these intense X-ray supernovae, the consequences could be severe. The radiation would strip away a significant portion, up to 50%, of the ozone layer. This protective barrier shields Earth from harmful ultraviolet radiation. Its depletion would be enough to trigger a mass extinction event. Even worse, the danger doesn't end there. While X-rays would strike Earth relatively quickly, the cosmic rays generated by the explosion would take hundreds of thousands of years to arrive, bombarding the planet's atmosphere long after the initial damage had been done. These rays could prevent the recovery of the ozone layer and continue to expose life to harmful radiation. Fortunately, astronomers have not identified any potential X-ray supernova candidates in our immediate cosmic neighborhood. But the realization that these explosions are more dangerous than once believed has implications for our understanding of where life can safely exist in the universe. The galactic habitable zone, the area within a galaxy where conditions might support life, may need to be redefined. The outermost regions of galaxies often lack the heavy elements needed to form rocky planets, while the densely packed cores of galaxies experience frequent supernovae, constantly bathing their surroundings in deadly radiation. New research suggests that the safe zone for life might be farther from the galactic center than previously assumed. As for Betelgeuse, the red supergiant star at the heart of this growing curiosity, its eventual supernova explosion will be a spectacle unlike anything witnessed in modern history. Though Earth's biosphere will likely remain unharmed due to the star's distance, the event will not go unnoticed. When Betelgeuse explodes, it will shine with a brilliance that rivals the Moon. For over 3 months, it will glow with half the brightness of a full moon, concentrated in a single brilliant point in the sky. Even during the day, this celestial beacon will be visible. At night, it will cast shadows and draw the attention of everyone who glances upward. The explosion will remain visible to the naked eye for at least a year and possibly longer, as the glowing remnants of the supernova slowly fade away. It will be a once-in-a-lifetime moment for humanity. An extraordinary light show from across the galaxy that reminds us of the power and unpredictability of the cosmos. And though Betelgeuse may not pose a direct threat, its eventual death will leave a permanent mark on the sky and a lasting impression on everyone who sees it. At Waves Discovery, we continue to explore these astonishing truths of the universe, bringing you closer to the wonders and the risks that lie